when a body which is resting on a surface, if we apply a force on the body, there will be a resisting force which is in the opposite direction of tendency of motion or motion of the body. That force is called as frictional force. In this problem, in this arrangement, we have two bodies A and B, where A is placed over B, and we are applying an external force of P on body B in this direction. Then the body A is also connected to this vertical wall using a string, using a inextensible string. So when we apply force P in this direction, on this body, the frictional force will be acting in this direction at this contact surface, and also at this contact surface, contact area also, there will be a frictional force in this direction. Okay, so if you consider this body, due to the application of this force on body B in this direction, the frictional force will be force on block A will be acting in this direction. Okay, because this body, if you consider this body only, this body will have a tendency to move in this direction under the action of the string tension. Okay, so if you draw the free body diagram of A, this is block A, it will have its weight acting downwards, a normal reaction from block B, let it be RB, and let this be W1. This is given as 200 Newton. There is RB, then the tension T in this string in this direction, and as this body will have a tendency to move in this direction, the frictional force will be like this. F is equal to frictional force F equal to mu into RB. Here, for all the surfaces, mu is given as 0.3. Mu is given as 0.3, where mu is the coefficient of friction. And at this contact surface or the bottom of block A, the frictional force, that is the limiting friction, F is equal to mu into RB. Now, how limiting friction is coming into play? Because we are considering or assuming that the force P, the magnitude of force P, is just about to move block B. Just to move block B. That means limiting friction is applicable. So if limiting friction is there, F is equal to mu into RB. Now, for the block A, we can see that it is not moving in the vertical direction. In this direction, it is not moving. It is having a tendency to move in the horizontal direction only, because block B is supporting it in the vertical direction. Therefore, sigma V equal to 0 for block A. Let us consider block A. For that, sigma V equal to 0. That is, algebraic sum of all the vertical forces is equal to 0. So for block B, these are the vertical forces, that is 200 Newton weight acting downwards and RB acting upwards, where RB is the normal reaction from block B. So RB is taken as positive because it is in the upward direction, minus 200 equal to 0. That gives RB equal to 200 Newton. That will be RB will be equal to 200 Newton. Then, if we consider sigma H equal to 0, that is the horizontal forces or sum of horizontal forces acting on block A, that also will be equal to 0, because the body, these two bodies will be in equilibrium under the action of these forces, because the force P is just to move body B, and also A is not, we can easily say that the block A is not moving, but it is having a tendency of motion. So we can assume sigma H equal to 0. That means for the block A, T and mu RB are the two horizontal forces acting on the body A, block A. That is, mu RB is taken as positive, minus T equal to 0. Mu RB minus T equal to 0. So mu is 0.3, that is already given. RB is 200 Newton, minus T equal to 0. That gives T equal to 60 Newton. So that is the tension in the string. So the tension will be acting like this on the string. This is T. So for this block, T is in this direction, and T, the value of T is, magnitude of T is 60 Newton. Now consider block B. So the free body diagram of block B will be like this. Its weight is given as 300 Newton. It is in the vertically downward direction. And the reaction from A, or its weight also will be acting on block B. So it is 200. Either the reaction or the weight of the block A is as 200. Then the reaction from the horizontal floor, that is R F, let it be RF, where RF is the normal reaction from the floor in the upward direction on block B. Then we have the force P in the horizontal direction. Then as this block under the action of P, it is having a tendency to move in this direction, the frictional force at the contact surface between the floor and the block is mu is same into the normal reaction RF. And between the contact surfaces of block A and B, again, this will be the direction of the frictional force, and that will be equal to mu into RB, that we have already found out, mu into RB. The same frictional force will be acting on this block also. So it is mu into RB. So these are the forces acting on the block B, which is resting on the floor below block A. The sigma Fv equal to 0 is equally applicable on block B also. That is, sigma V equal to 0. For block B, if you apply sigma V equal to 0, that is algebraic sum of all the vertical forces acting on block B equal to 0, it will be, the equation will be RF is in the upward direction, is taken as positive, minus 200 minus 300 equal to 0. That gives RF equal to 500 Newton. that gives Rf is equal to 500 Newton. Then applying sigma h equal to 0, that is algebraic sum of all the horizontal forces acting on block B equal to 0, because this under the action of P and the other horizontal forces, it is in equilibrium, or the body is just about to move just before motion. It is not moving, it will move in the next moment. So sigma h is equal to 0 means P is taken as positive because it is acting in the left to right direction. So P minus mu into Rf minus mu into Rb, that is equal to 0. Now Rf we have already got as 500 Newton, mu's value is given as 0.3, and Rb we already got from this equation, that is 200 Newton. Substituting all these values, P, or you can write this equation as P is equal to mu into Rf plus mu into Rb. When you substitute the values, we will get P is equal to mu is 0.3 into Rf is 500 plus 0.3 into 200 will give you P equal to 210. So that will be the value of P.